Hi, let's see another interesting triple integral. Integral from minus infinity to infinity. Here minus infinity to infinity. Again minus infinity to infinity. X plus y sine of x sine of y over x square plus z square times y square plus z square dz dy dx. Okay, what do you think? How to begin? Well, first here minus infinity to infinity, again minus infinity to infinity, again minus infinity to infinity. Now here we have in the numerator x plus y times sine of x times sine of y over these terms x square plus c square times y square plus c square. So let us simplify a little bit. So I am going to take this part here, x square plus c square times y square plus c square, and now I am going to subtract these two terms in the numerator. So here we have x square plus c square minus y square plus c square. Then here we have c square minus c square get cancelled, and in the numerator we have x square minus y square. So we should divide by x square minus y square, and here we have dc dy dx. Okay, then as a next step, we know here x plus y get cancelled because in the denominator we have difference of two squares. So we can write now minus infinity to infinity, integral from minus infinity to infinity. Here now we know x plus y get cancelled, so sine of x sine of y over x minus y, and again integral sign minus infinity to infinity. Now if we divide it by x square plus c square times y square c square, we know x square plus c square get cancelled, and we have 1 over y square plus c square, then here minus, and we know this term also get cancelled, and we have 1 over x square plus c square, and here now we can write dc dy dx. Okay, then we are going to evaluate this integral. We know this is a simple integral because arctan, so we can write this is equal to 1 over y arctan of c over y, arctan of c over y minus 1 over x arctan of c over x from limit we know minus infinity to infinity. Okay, now if we plug in infinity, we know arctan of infinity pi over 2, and again here we know we should subtract lower boundary, so minus we know plus, so here we have 5 over 2 plus 5 over 2 5, so 5 times 1 over y minus 1 over x. Okay, then we can write our integral is equal to, now here pi is a constant, so we can write outside of the integral sign, so here pi, now minus infinity to infinity, again minus infinity to infinity. Now here we have sine of x sine of y over x minus y times now here we have 1 over y instead of this integral. This is the answer, 1 over y minus 1 over x, here dy dx. Okay, then if we simplify this, common denominator we know xy, and in the numerator we have x minus y, so x minus y get cancelled. So we can write now this is equal to pi times integral from minus infinity to infinity, again minus infinity to infinity, sine of x sine of y. Now we know x minus y get cancelled, and here we have only xy in the denominator, and here we can write now dy, here dx dy. Okay, then we can rearrange our this double integral like minus infinity to infinity sine of again minus infinity to infinity sine of x over x dx, then here sine of y over y dy. Okay, now here we have another interesting integral, and we know we have a shortcut to evaluate that integral, mass identity. So I created many videos about mass identity. If you like to watch, I will add the link in the description, and also you can search in YouTube. Okay, here now we can write our integral minus infinity to infinity sine of x over x dx, and we know according to symmetry we can write this is equal to 2 times 0 to infinity sine of x over x dx. Now we know mass identity, a very cute Laplace transform identity. So we can write now this is equal to here 2 0 to infinity Laplace transform of sine of x times inverse Laplace transform of 1 over x dx. Okay, then we know Laplace transform of sine of x is equal to 1 over 1 plus x square, and inverse Laplace transform of 1 over x we know 1, so here only dx, and we know this is also arctan, so arctan of x from 0 to infinity here 2, so here 2. If we plug in, if we apply limits, we know here pi over 2, so here 2 times pi over 2 we know pi. Okay, then we can write our integral is equal to here pi square, because instead of this integral we know the answer is pi, so here pi, so pi square. Now here minus infinity to infinity sine of y over y dy. Okay, sine of y over y, same integral, so we know the answer is pi, so here pi square times pi, the final answer is pi cube. Okay, this is the answer. If you like this type of videos, please subscribe this channel. Thank you for watching.